Hey guys, good morning. Hey, it's Wednesday, April 8th. Algebra 2 here. Turn in your book to page, what is it? 393. So follow along, page 393. This is lesson 6.2. Page 393, 6.2. Let's get right after it. Okay, we're looking at inverse relations and functions. Okay, inverse relations. When you think of inverse, think of all we're doing is we're going to invert it. We're going to turn it upside down. So we're just going to change it in terms of turning it upside down. And we're going to do that with an ordered pair. So take a look at what we got in example 1 here. We have inverse relations. Okay, our normal ordered pair obviously is xy. Right? The inverse of that, and these are related, the inverse relation, the inverse of this is where you just switch the x and the y. So it goes from xy over to yx. So let's take a look at a few examples here. 4, 2. If I have 4, 2, if I take the inverse of it, I just switch the x and the y, I come up with 2, 4. Negative 6, 5 changes to 5, negative 6. Negative 0, negative 5 is going to turn out to be negative 5, 0. Okay? So now let's take a look at what that's going to look like if we graph it. So the inverse of an ordered pair is just when you switch the x and the y. So let's take a look at this graph. We graph those same points. Here's my original points right here. 4, 2, 5, negative 6, negative 0, negative 5. So these are my first points. Okay? I look over here, and when I take the inverse of it, I switch the x and the y, and what comes about is when you have that graph, okay, it's going to be reflected in this line, okay? And that line is y equals x. So anytime you take the inverse of something, that graph is going to be reflected in this line, which is y equals x. And that line basically is if we put 1 in for x, 1 would be y. Whoops, 1. If we put in 3 for x, 3 would be y. Okay? And we see that this line is going to be y equals x. So that is always going to be reflected in the x-axis. Okay? Always going to be reflected in the x-axis. So when we take the inverse of it, we just are going to flip the x and the y coordinates. And then when we graph it, it's going to be reflected in y equals x. Okay? The second thing we're looking at is when we take a look at page 394. So head to page 394. Okay? 394, when we're finding the inverse of something. Okay? Finding the inverse of a function. Okay? So let's take a look at example 2. When we find the inverse, we have an original equation, an original function of x equals 2x minus 5. So we remember that f of x equals y, right? That's my ending value. So f of x equals y, so I can replace y in for f of x. So right here, I take my f of x, replace the y. So now I have my function, my equation, y equals 2x minus 5. When I have this, and now I want to take the inverse of it, all I'm going to do is switch the x and the y variables. So as I see here, I change the x over to where the y is, and I put the y over where the x was. You're just switching the x and the y, and now we have this function. This is going to be the inverse. Now, what we want to do to graph it is we want to always put it back into slope-intercept form. Okay? So, as we look here, okay, as we look here, whoops, okay? When we have here, now we want to put this back in slope-intercept form. So we have x equals 2y minus 5. We add 5 to both sides. X plus 5 equals 2y. Divide by 2. Divide by 2. Y equals, x over 2 is the same as 1/2 x plus 5 over 2. Okay? So we put it back in, and then we would end up putting this back in slope-intercept form, and then it would end up being y equals 1/2 x plus 5 over 2. Okay? Y equals, so we put it back in slope-intercept form. So what we're basically doing is switching the x and the y's, and then we turn around and solve for y and put it back in slope-intercept form so we can graph it. Okay, put it back in slope-intercept form so we can graph it. Let's take a look at one other example here. Okay, one other example. Here's my function. F of x equals x minus 3 over 5. Okay, I replace my y, my f of x with my y. Then all I do is I'm going to switch to find the inverse. I'm going to switch the x and the y. So my y comes to where my x is, my x comes to where my y is. And now I'm going to put it back in slope-intercept form so I can graph that. So in this example, I want to eliminate my denominator. Times 5 times 5. Now I have 5x equals y minus 3. Add 3. Y equals 5x plus 3. Put it back in slope-intercept form. Y equals 5x plus 3. So we put it back in slope-intercept form. So now this is easy to graph once I put it back in. Now, when I graph this, the inverse of my original equation, where's it going to reflect when I graph those two? It's going to reflect in my equation y equals x. So it's going to be reflected. So the inverse is going to be reflected in this line. Okay? It's going to be reflected in this line. All right? So that's example 1 and example 2. Let's take a look at example 3. In example 3, what we're looking at doing is we're verifying our inverses. So this is on page 395. We're verifying if something is an inverse. Okay? Now, think of when we're verifying, we want it always to, if it equals x, then it's the inverse. Okay? Star means it's going to be the inverse. So it needs to equal x. Okay? So take a look at example 3. We're going to do 2 examples here. Take a look at example 3. 3x plus 9. Okay? That's my first example. My function, 3x plus 9. And my other one is my g function, which is 1/3 x minus 3. Okay? So when I'm trying to verify if they're inverses of each other, I'm going to basically do the composition. I'm going to do a composition function of f of g of x, meaning I'm going to plug my g function in for x of my x function. Okay? So I'm going to replace my x here with 1/3 x minus 3 plus 9. Okay? So I replace it, and then I'm going to solve for this. 3 times 1/3 x is x. 3 times negative 3 is negative 9. Plus 9 equals x. Okay? When we go the other way, we're going to plug in 3x plus 9 in for x here. So we have 1/3 times, right? Because I'm going to take this, plug it back into my x, 3x plus 9 minus 3. 1/3 times 3x is x. 1/3 times 9 is 3. So I distributed this to both terms. X plus 3 minus 3. Just like up here, those two cancel. Those two cancel. I'm left with x. So those two would be inverse functions of each other. Okay? Inverse functions of each other. All right? So remember, when you're doing the inverse function, if you're trying to verify, this is example 3, if you're trying to verify that something is an inverse function, do a composition function. Substitute one function into the x of the other function. And plug in the g function in for the x of the other function. Okay, so that's how you verify if functions are inverses of each other. All right, so we're going to end it there. Let you work on it. Let me know if you have questions. We'll be happy to, again, get together and take a look at it. But that's your assignment today, and we will talk to you in just a little bit. And your next assignment after this will be on Monday. So I hope the assignment for Monday went well and that you're working through it on the little project I gave you. So we will see you soon.